Hi, welcome to Coding Bootcamp's YouTube channel. Subscribe now and join our live stream session later. See you.
Welcome everyone. Welcome to this course, Introduction to Blockchain Development with Hyperledger Fabric. This course is brought to you by Coding Bootcamps. In this course, we are going to learn what blockchain is and how to build blockchain application with Hyperledger Fabric. A little bit about myself. My name is Sushma and I have a master degree in computer science and information security. I also have a master degree certification on blockchain. I have 6+ years of experience in industry. I have been a Java developer, web developer, full stack engineer, and also a tech lead in my career lane. My main interests at the moment are blockchain, IoT, DevOps, and cloud infrastructure. What are the prerequisites you need to have to take this course? You need to have basic knowledge of Linux commands and basics of Node.js, and you should be enthusiastic to learn blockchain technology. That's all you need to take this course. In this course, we are going to discuss the high level topics. Those are the overview of the blockchain technology, anatomy of the blockchain technology, Hyperledger blockchain ecosystem. Then we are going to have a deep dive into one of the Hyperledger ecosystem member, which is Hyperledger Fabric. And we are going to learn all about the components of Hyperledger Fabric and the architecture of Hyperledger Fabric. We also have an interesting section where we build supply chain distributed application with Hyperledger Fabric. In this section, we will learn how to design the supply chain distributed application that we are going to build with Hyperledger Fabric. We were going to write the chain code and smart contracts. We are going to compile those and we are going to deploy those. Then we are going to run and test the smart contract. With that, we will also develop an application with Hyperledger Fabric through the SDK. From this course, you can learn what exactly blockchain is. You will get a strong understanding of how blockchain technology works. You will get a strong understanding of what Hyperledger and its ecosystem is. You will also have a strong knowledge on how Hyperledger Fabric components work together, and you will have a real world project to show at the end of this course. If you want to have any follow-up classes, please click on this link where you can learn more about Hyperledger or other blockchain networks like Ethereum, and we also have the Solidity programming language as well. Please click on these links to know more. And all these are available in coding-bootcamps.com. Please do log on to coding/bootcamp.com to know more. Thank you for watching. Hello everyone. Welcome to this course, Introduction to Blockchain Development with Hyperledger Fabric by Coding Bootcamps. In this section, we are going to learn what blockchain technology is. A little bit about myself, who is your instructor. My name is Sushma and I have 6+ years of experience in industry. I hold a master degree in computer science and information security. I also have a master degree certification on blockchain. I have played a role of a Java developer, web developer, full stack engineer, and also a tech lead in my career lane. Prerequisites for taking this course. You should have basic knowledge of Linux command and basic knowledge of Node.js to write the smart contracts, and you should be willing to learn blockchain technology. In this session, we are going to see what blockchain is, what are the types of network, what are blockchain components, what are the use cases of blockchain, and what are the examples. So before jumping into what blockchain is, let us understand what is the difference between centralized model or centralized system and decentralized model or decentralized system. So in case of centralized system, which you can see on the left side, you can see there is one central authority or one central organization who is holding the data. So one organization is responsible for maintaining the data in the system. So if you want to be part of that system, you should trust that central authority with the data that you are providing to that organization. But in case of decentralized model, as you can see, there is no centralized authority of data. So each peers or each participant in the network can talk to each other and exchange data between them. So in the decentralized model, you don't invest your trust only on one single authority or one single organization. Instead of that, you build your trust on the network. So this is where blockchain comes in. With blockchain, we move away from trusting only one central authority. Instead, we trust the system. So now let us see when and how blockchain came into picture. So blockchain became popular because of Bitcoin. So Bitcoin was originally devised for digital currency exchange. The underlying technology that Bitcoin uses is blockchain. After the popularity of Bitcoin, many innovative ideas have come forth which can take advantage of the blockchain technology. So, blockchain technology is a system that uses many existing technologies like peer to peer network, digital signature, hashing algorithm, etc., and it forms a blockchain system. So, who coined this term? A person or organization. We don't know whether Satoshi Nakamoto is a person or an organization, so it is a pseudonym. So he or that person is responsible for coining this system. Now let us understand the definition of blockchain given by hyperledger.org. A blockchain is a peer-to-peer distributed ledger forced by consensus combined with a system for smart contracts and other assistive technologies. What do you mean by that? Now let us see what do you mean by peer-to-peer distributed ledger. It means it doesn't have to deal with a single server, so it is peer-to-peer. So there is no single authority, single central authority. So all transaction data of the system will be available with each peer, as we have seen in the decentralized model in the previous picture. So forged by consensus. What do you mean by consensus? What transactional data that has to be stored in the distributed ledger is decided by a process, and that process is called consensus. And what do you mean by smart contract? So smart contracts are the programs that we place it on the network, and when certain conditions are met, smart contracts will execute on its own. What do you mean by other assistive technology? As I mentioned before, blockchain is a system that uses many existing technologies like peer-to-peer network, digital signature, hashing algorithm, and etc. So these are the other assistive technology that it uses. But why the name blockchain? So block refers to a set of transactions that are bundled together and added to the chain of every peer at the same time. Next block will be appended to the existing block and the process continues and it forms a chain. That is why the name blockchain. Moving on to types of network. Blockchain network is majorly categorized into the following sections, which is public blockchain network, private blockchain network, permissioned or consortium blockchain network. Each of these types have their own implementation. Couple of examples for them are given in this section. Now let us understand what are the difference, where it is used, what are the benefits and challenges of all these three types of network. First one is public network, second one is private network, and the third one is permissioned or consortium network. What is the network type? So in public network is completely decentralized and private network is partially decentralized. Consortium network is partially decentralized. It can be a combination of both public and private networks. So who can take part in public network? So anyone like you and me can participate in the network, and data is validated by every participant or every peer, thus making it secure. So not everyone can be part of private or consortium network. So permission to read and write on the blockchain is controlled by the owner of the blockchain. And in case of consortium network, permission to read and write on the blockchain is controlled by predetermined nodes. What are the benefits of public network? So public network is secure as the entire network verifies the transaction, meaning entire peers verify the transaction. It is transparent as all the transactions are made public with individual anonymity. In case of private network, it is efficient as verification is done just by the owner of the blockchain. So only the owner can have an access to read and write. In case of consortium, the benefits are these are also efficient because only a known number of nodes who forms the consortium can verify the transaction. So the read and write authority is distributed among predetermined nodes. So what are the challenges of public network? Here the efficiency is low because entire network verifies the transaction. So the efficiency is low. In case of private network, the controlling power is consolidated to a single authority who is the owner of the network. In case of consortium network, the controlling power is consolidated to a single organization who has formed the consortium and who is acting as a leader of the consortium. If you don't understand more about consortium, when we get to the next sections, so you will understand what you mean by forming a consortium and other topics around it. So don't worry. Now you might ask a question, do I need blockchain for every use case? The answer is no. So there are certain use cases which needs blockchain. There are certain use cases which doesn't need blockchain. So in this slide, you can see which are the use cases which fits into blockchain, which are the use cases which doesn't need blockchain. For your application, do you need a database? If the answer is no, then you don't need a blockchain. If the answer is yes, then you have to ask again a question. Are there multiple writers to the database or the ledger? If the answer is no, then you don't need blockchain. If the answer is yes, ask yourself again another question. Are all writers trusted? If the
Thanks for watching. Feel free to add your questions as comments down below.
answer is yes, you don't need blockchain. If the answer is no, the writers are not trusted, then you have to ask yourself another question. Do they have someone in common they trust, which is a third party? If the answer is no, then you definitely need a blockchain. If the answer is yes, then you don't go for blockchain. So, this is the simple way of explaining or deciding whether your application or your use case fits into blockchain or not. So, what are the components of blockchain? So, there are main four components of blockchain. First is consensus. So, consensus refers to a system of ensuring that parties agree to a certain state of the system as the true state. Provenance. Provenance system tracks changes that are made to data, where data originates and moves to, and who makes changes to it over time. Immutability. An immutable object is an object whose state cannot be modified after it is created. Finality. Finality is the affirmation that all well-formed blocks will not be revoked once committed to blockchain. So these are the main four components of blockchain. Coming into use cases of blockchain, there are many use cases of blockchain, and many industries are working towards in bringing blockchain and adapting blockchain for their use cases. Listed are couple of them. First is decentralized cryptocurrency, asset management like trade processing and settlement, payment like cross-border payment, IoT, smart appliances, smart chain sensor, blockchain healthcare, blockchain music, blockchain government, personal identification, and many more. Please go through this link. So this link has 50 plus real world blockchain use cases, and you'll also find the companies who have already included their application, and they are already in a building phase of these blockchain use cases. That is it for this lecture. In the next session, we'll learn what blockchain structure is, the blockchain lifecycle, and how to write smart contract, different consensus algorithms that are supported, players in blockchain, and many more topics. To know more and to get more understanding of blockchain, please please look into these links, and please do subscribe to our private coaching sessions. Thank you. Welcome back again. In this section, we are going to look into anatomy of blockchain. In the previous section, we have learned what blockchain is, what are the types of network, what are blockchain components, use cases and examples of blockchain. In this section, we are going to see what blockchain structure is, what is blockchain lifecycle, smart contract, different types of consensus algorithms, players in blockchain, etc. Now let us understand from this slide how blockchain works. So blockchain technology is a peer-to-peer distributed ledger that can record all transactions of two parties securely and efficiently. As it is distributed, these transactions are stored inside block, and blocks are linked to form a chain. The creation of the block is done through a process called consensus, and this consensus should be achieved in peer-to-peer network by each peer in the network. So in this consensus process, each peer works simultaneously to solve a complex mathematical problem to validate the next block. Once the block is added to the blockchain, you cannot change it. Even if you try to change it, it is easy to verify that it is a malicious data. This is the reason why blockchain is secure. In this slide, you can see how blocks are stored in blockchain. As you can see, every block, you can consider this as one block. So you have 3 blocks in this picture. Every block contains different fields. When I say fields, the inside content, which are previous hash, timestamp, transaction root, nonce. So these are the different fields that are present in a block. One interesting field is transaction root. As you can see in this picture, every transaction is hashed to a value and it is consolidated to certain level to form a transaction root. So how this transaction root is achieved? This is achieved through something called Merkle tree. Now let us see what Merkle tree is. Merkle tree is a data structure and it is nothing but a binary hash tree. Merkle tree stores the hashes of individual data, individual transaction in a tree structure or a tree format, which makes the verification of the dataset or the transaction efficient. Merkle tree summarizes all the transaction in a block, producing an overall digital fingerprint of the entire set of transactions. Because of Merkle tree, you can easily verify whether a transaction is part of the chain code or not. So the life cycle of a transaction on blockchain differs from one framework to other framework. For example, life cycle of a transaction on Hyperledger Fabric will be different from life cycle of a transaction in Bitcoin. In this slide, let us understand the life cycle of a transaction on Hyperledger Fabric. So it starts with enrolling the users and application. So MSP, which is Membership Service Provider, is responsible for this. MSP provides the identities for all the entities in the application or in the system. After the enrollment, the application is responsible to submit the transaction to the transaction. Sorry, after the enrollment, the application submits the transaction proposal to endorsing peers. We will get into the different types of peers in the coming lectures. Now let us just understand there are a unique type of peers which has chain code installed on it. So application submits the transaction proposals to those endorsing peers. So endorsing peers simulate the transactions and respond back to the application. Then application then submits the transaction to the orderer. Orderer sorts the transaction, assembles block and send to committing peer. So committing peer validates the transaction and updates the ledger. This is the simple way of explaining how transaction works in Hyperledger Fabric. We will see much more detailed process as we move ahead in this course. As I told, the life cycle of a transaction is different in different blockchain framework. Now let us see how Bitcoin transaction lifecycle works. The life cycle of a transaction on Bitcoin block is as follows. So basically, Bitcoin is a currency transfer platform. A peer initiates a transaction and it enters the destination Bitcoin address. And it also enters the amount that has to be transferred to the destination contract, destination Bitcoin address. After that, it the it authorizes the payment using private key. So this transaction should be validated by the miner by all miners, and miners are nothing but the peers in the network. So miners solve the proof of work problem and propagates new block to the network. Other miners verify the new block and the payment will be sent to the destination address. So this is the entire process which involves transferring of a Bitcoin from one account to another account by the process of miners mining a new block, and other miners in the network validate that block and add that block to their network. So this is how Bitcoin transaction lifecycle works. Now let us see what is a smart contract. So smart contract is a computer code running on the blockchain network. It contains a set of rules under which parties agree upon a certain number of predefined rules. When these rules met, the agreement is automatically enforced. So smart contract between two parties is mainly for transferring digital assets in the network. Now, from this slide, let us understand how smart contract works in a nutshell. So the step 1 in the smart contract is smart contract is written as code and it is deployed as code on the blockchain. Step 2, when certain events occur, the smart contract code will get automatically executed. In step 3, which will lead to transfer of assets from one party to another in the network. Step 4, since these transactions, like all the transactions, is stored in an immutable data structure, which is blockchain. So any regulator can verify this transaction. Now let us see what is consensus algorithm. So in order for the network to decide which transaction should form a block, where it should be placed in the blockchain, consensus algorithm should be in place. Consensus algorithms are designed to achieve reliability in the network involving multiple nodes or multiple peers. There are different types of consensus algorithm, which is proof of work, proof of stake, practical Byzantine fault tolerance. Now let us understand what proof of work is. So proof of work is a system that is used to process blocks of transactions and add them to the blockchain. Here comes a term called mining. So what is mining? So mining is a process. It is a process of generating correct proofs in order to add a block to the blockchain. And individuals that participate, those who participate in the mining process are known as miners. So proof of concept was first used by Bitcoin blockchain system. So proof of work requires miners to solve complex cryptographic puzzles before they can add a block to the blockchain. In exchange for solving a puzzle, the miners are rewarded with a Bitcoin. Now let us see what is proof of stake. So in case of proof of stake system, miners are the peers that are chosen to generate to form a block. and these miners are called
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
validators. Now you might ask a question, who can be a validator? How validators are chosen in the system? In proof of stake system, the validators are chosen to generate a new block based on their economic stake in the network. So if you have higher stake in the network, there's a higher chance of you becoming a validator. Next one is Byzantine fault tolerance. Before getting into Byzantine fault tolerance, let us understand what is Byzantine general problem. This is the scenario. Imagine a group of generals, each commanding a portion of Byzantine army, encircled a city. They must decide whether to attack the city or retreat. Whatever they decide, the important thing is that they have to reach a consensus. But consensus is difficult to reach because the generals in this army also cannot trust each other. You can draw the analogy of the real world, just like we cannot trust each other online. So the one general might say they plan to attack when they actually plan to retreat. Because of one dishonest person, which is the general, everyone else order who take this order into account dies in the battle. This is something called Byzantine general problem analogy. So this is the main issue faced by Bitcoin network, and in order to avoid that, or in order to bring solution to that problem, we have Byzantine fault tolerance. Now, what is Byzantine fault tolerance? Byzantine fault tolerance is the ability of a distributed computer network to function as a desired and correct to function as desired and as correctly to reach a sufficient consensus despite of the malicious node in the system who tries to propagate incorrect information to other peers in the network. The main objective is to defend against any catastrophic system which leads to failure by mitigating the influence of malicious nodes who are participating incorrect information. As a result, we can reach the right consensus by honest nodes sending the right information. Now, let us understand who are the players in the blockchain. So there are different players in blockchain. First one is blockchain architect, who is responsible for architecture and design of the blockchain solution. Second one is blockchain developer, the developer of application and smart contracts that interact with blockchain and are used by blockchain users. Blockchain users, these are the business users or operating in the business network. This role interacts with the blockchain using an application which is written by a blockchain developer. They are not aware of the blockchain. Blockchain regulator, the overall authority in a business network. So specifically, regulators may require broad access to ledger's content. Who are the actors in blockchain has this slide as well, which continues, which is blockchain operator. Blockchain operator is the one who manages, monitors the blockchain network. Each business in the network has blockchain network operator. Membership services. It manages different types of certificates required to run a permissioned blockchain. As we have seen, something called MSP. We will discuss more about MSP in the coming lectures. So traditional processing platform, an existing computer system which may be used by the blockchain to augment processing. This system may also need to initiate requests into the blockchain. Traditional data sources, an existing data system which may provide data to influence the behavior of smart contract. Now let us see what are distributed apps, short form, It is called dapps. A DApp has backend code running on decentralized peer-to-peer network. The smart contracts with this, uh, the contract with this, uh, contract this, contrast to this, we have backend code running on centralized server. To reiterate the step 2, so you have the backend code running on peer-to-peer network, which means the backend code will be running on each peer, contrast to it is running on one single centralized server. So DApp can have front-end code and user interfaces written in any language, and these can make calls to backend which are running in peer-to-peer network. Furthermore, its frontend can be hosted on decentralized storage such as Swarm or IPFS. So, if an app is equal to frontend and backend, which is server, since Ethereum contracts are codes that run on the global Ethereum centralized peer-to-peer network, that's why the dApps are nothing but frontend plus contracts which are running in peer-to-peer network. That is it for this section. In the next section, we will look into the family and design philosophy of Hyperledger Fabric and other architectural aspects of Hyperledger Fabric. Please subscribe to our private coaching lessons to learn more. Thank you for watching. I'll see you in the next section. Welcome back again. In this section, we are going to look into Hyperledger blockchain ecosystem. In previous section, we have learned how blockchain works, what is blockchain structure looks like, what are smart contracts, and what are the different types of consensus algorithm. In this section, we are going to look into Hyperledger blockchain ecosystem, which includes the family introduction, design philosophy, and framework architecture of Hyperledger Fabric. So what is Hyperledger Fabric? So before that, let us see what Hyperledger is. So Hyperledger is an open source community focused on developing a suite of stable frameworks, tools, and libraries for enterprise-grade blockchain deployment. It serves as a neutral home for various distributed ledger frameworks, tools, and libraries. So Hyperledger family comprises of distributed ledgers, libraries, tools, and domain-specific projects. Inside distributed ledger, we have many, couple of them are listed here. First one is Hyperledger Besu. Besu is a distributed ledger it is a distributed ledger software and is an Ethereum client designed to be enterprise friendly for both public and private permission network use cases. Next is Hyperledger Bureau. It is a complete single binary blockchain distribution focused on simplicity, speed, and developer ergonomics. Hyperledger Fabric. Hyperledger Fabric is the main focus of this course, and in a nutshell, Hyperledger Fabric is a distributed ledger software and it is intended as a foundation for developing applications or solutions with a modular architecture. We'll look more into this in the coming sessions. Hyperledger Indy. It is a distributed ledger software, and Indy provides tools, libraries, and reusable components for providing digital identities. Hyperledger Iroha. It is designed to be simple, easy to incorporate into infrastructural or IoT projects requiring distributed ledger technology. Hyperledger Sawtooth. This is a distributed ledger software again that helps smart contracts to specify business rules for applications without needing to know the underlying design of the core system. In libraries category, we have Hyperledger Arrays. This provides a shared, reusable, interoperable toolkit designed for initiatives and solutions focusing on creating, transmitting, and storing verifiable digital credentials. Hyperledger Quilt. Quilt is a Java implementation of Interledger Protocol, enabling payments across any payment network. Hyperledger Transact. This aims to reduce the development effort in writing distributed ledger software by providing a standard interface for executing smart contract. Hyperledger URSA. URSA is a shared cryptographic library. It enables implementations to avoid duplicating other cryptographic work, thus increasing the security in the process. Under Tools section, you have Hyperledger Avalon. This is a tool. It aims to enable the secure movement of blockchain processing off the main chain to dedicated to computing resources. Hyperledger Caliper is a blockchain benchmark tool. It measures the performance of blockchain implementation with a set of predefined use cases. Hyperledger Cello. This facilitates creating blockchain as a service. Hyperledger Explorer. This is a web app tool used to view, invoke, deploy, or query blocks or transactions and the associated data or network information. Next, we have domain-specific projects, and Hyperledger Grid is one of the domain-specific project in Hyperledger blockchain ecosystem. This intends to provide reference implementation of supply chain. In this slide, you can see what are the Hyperledger projects which comes under the category distributed ledger, library, tools, domain specific, and you can also see their status, whether they are already in active or whether they are still in incubation state. So Hyperledger design philosophy. As you can see in the slide, many companies have adapted Hyperledger because of its design, meaning it is highly modular in nature and its governance is very transparent. So that is the reason many of the companies have already adopted Hyperledger. So Hyperledger framework architecture. Hyperledger focuses on these main business blockchain components those are consensus layer, smart contracts, database, peer networking, security, and many more. In this slide, you can see the main business blockchain components and the key functionalities and responsibilities of those business blockchain components. Please go through this slide to know the business blockchain components that we have mentioned and the responsibilities of those components. We will learn couple of the blockchain component as we move ahead learning Hyperledger Fabric. So each of these blockchain components is itself a topic to discuss because some of the topics like identity services, API, or smart contract layer or consensus, so they form a, a topic itself which we will be discussing in terms of Hyperledger Fabric specifics. So there are many consensus algorithms that Hyperledger community is working on to cater to various business requirements. Two major types of consensus are permissioned lottery-based algorithm and permissioned voting-based algorithm. Each of these types have their own implementation. For example, permissioned lottery-based algorithm has the implementation proof of work and proof of elapsed time, and permissioned voting-based algorithm has
Thanks for watching. Please like and share this video.
RBFT and Paxos. This slide lists the Hyperledger framework and the consensus algorithm that we use currently and the pros and cons of those consensus algorithm. Please have a look at this slide to understand different Hyperledger framework and the consensus algorithm that is used. The main focus for this and the next upcoming lessons are Hyperledger Fabric. We will discuss the consensus algorithm that is used in detail in the upcoming lecture. Here is a small test for you to gauge your understanding of the concept so far. Please try answering it and I'll see you in the next section. Please do subscribe for our private coaching sessions to learn more. Thank you. Hello everyone. Welcome back to this section where you will learn the components of Hyperledger Fabric. So this is kind of important section where you will learn the components and architecture of Hyperledger Fabric, and it includes lot of components and also the details of those components. So please pay attention to this section. So in the previous section, we have learned about Hyperledger projects, which comes under the subsection Distributed Ledger Framework, Libraries, and Tools. So one such distributed ledger framework is Hyperledger Fabric. So to refresh your memory, Hyperledger Fabric is a distributed ledger framework and it is intended as a foundation for developing applications with a modular architecture. So in this section, we will deep dive into components and architecture of Hyperledger Fabric, and in the end, you will have a quiz to test your knowledge as well. So these are the components that Hyperledger Fabric framework is made of. Let me list out all this. First one is peer, next is ordering service, Fabric certification authority, Fabric ledger, Fabric channel, smart contracts or chain code, endorsement policies, MSP or membership providers. In this section, let us look into what peer is. So as you can see, peer is a fundamental unit of Hyperledger Fabric network. Peer maintains a ledger and a smart contract. Adding to that, peers are the fundamental element of the network because they host instance of ledger and instance of the chain code. Each peer can have multiple chain code and multiple ledgers. Peers have a special chain codes that are always present by default. Peers communicate to each other by using gossip protocol. A single peer is owned by a single organization, hence a single peer is associated with a single MSP. We will learn more about MSP as we move on. So as you can see in from the point 3, you can see there are different types of peers. There are anchor peer, lead peer, endorsing peer, committing peer. So what is anchor peer? Every organization must have one or more anchor peers so that those anchor peers can communicate to one or the other anchor peers of other organization using gossip protocols. This is needed to know about the peers that are present in other organization. Next is leader peer. This peer node receives a new block from the orderer and shares it with the other peers using gossip protocol. You will learn what orderer is in the coming sections. Next is endorsing peer. Endorsing peers has chain code installed on them. So Since they have chain code installed on them, endorsing peers simulate and endorse the transactions. Next is committing peer. Committing peer verifies endorsements and validates transaction results before committing a transaction to the blockchain. Moving on, peers can be created, started, stopped, reconfigured, and even deleted. They expose a set of APIs that enable administrator and application to interact with the services they provide. So what are the APIs? What are the services that the API provides? That we will see in the practical section. So in case of peer, the applications always connect to peers when they need to access ledger and chain code. The Fabric SDK, which is Software Development Kit, makes this easy for programmers. Its APIs enable applications to connect to peers, invoke chain codes to generate transactions, submit transactions to the network that will get ordered, validated, and committed to the distributed ledger, and receive events when this process is complete. This is how the application workflow works. So the workflow from application to peer and the communication that happens from application to peer, including the other ecosystem as well, we will see in the coming slides. So there are two types of the transaction. One is ledger query transaction, which requires 3 steps. We will see what are those three steps in the next slide, versus ledger update, which requires 5 steps. Let us see the example of this. So consider this blue box as blockchain network, and A, which is the outside application which sits outside the network, consider this as application. We are going to take P1 as the peer, we are going to take S1 as the chain code, we are going to take L1 as ledger, and we are going to take O1 as orderer. As we saw in the previous slide, ledger query takes 3 steps and ledger update takes 5 steps. Let us see what does that mean. When a ledger query happens, application connects to the peer. When application connects to the peer, application invokes the chain code on the peer. When it invokes the chain code, first what happens? The peer invokes the chain code with the proposal. Next, the chain code generates the query. Then again, after that, if it is a query, then the proposal response is sent back to the application. So this is the 3-step workflow that you follow in case of ledger query. When it comes to ledger update, application connects to the peer, then it invokes the chain code, which is the proposal. First step is peer invokes chain code with proposal, then chain code generates query or update proposal response, in this case update proposal response. After that, the proposal response is sent back to the application. Next, the request that the transition is ordered is sent to the orderer. What the orderer does is, orderer sends the transaction sent to peers in blocks. So orderer orders the transaction and creates the blocks, and these blocks are sent. After that, peers updates ledger using transaction blocks. Next, as part of concluding this process, the ledger update event occurs. So this is the 5-step process that happens in case of peer ledger update. So these are the steps that you need to keep in mind when you invoke a ledger query or a ledger update to your peer or to your network which consists of peers. So this is the explanation of what I just explained, and this depicts whatever the diagram says. So we do have one more course, which is Hyperledger Fabric System Admin course, where we majorly cover how peer interact with the application, how peer interact with one another, how peers are assigned to an organization, how peers interact with the orderer. So all these are very much necessary to understand in depth how peers as an ecosystem works with Hyperledger Fabric. So we do have that course. Please do check out that course as well, which is available on bootcamps. I'll see you in the next section. Thank you. Welcome back. In this section, we are going to see what ordering service or orderer is. So what is the role of this ordering service or orderer service or orderer component of in the Hyperledger Fabric ecosystem? So the mechanism by which applications and peers interact with each other to ensure that every peer's ledger is kept consistent with each other is mediated by a special nodes called orderers. So as you can understand from here, and also a couple of other examples that I have given in the previous lectures as well. So orderer makes sure that every peer's ledger is consistent across the network. This is the main purpose why we use ordering service in Hyperledger Fabric. So there are different types of orderer or ordering service in Hyperledger Fabric. First one is Solo, Kafka and Raft. So Solo and Kafka are deprecated in version 2.0 that is released by Hyperledger Fabric. The currently recommended ordering type is Raft. So ordering service is the orderer automatically broadcasts messages containing transactions to peers to be committed. All peers receive the same block of transaction in the same order. As we all know that orderer takes the transaction and makes a block and it is passed on to the peers, and peers will commit that block to their ledger. The ordering service orders transaction on the first come first serve basis for all the channels on the network. After the transaction is ordered, the records of the committed or grouped and assigned as part of the block for that communication channel. As I already mentioned in point 1, all the blocks that we get from the order, which is passed on to the peers, are committed to that particular ledger of the peer for a particular communication channel. Moving on. An update transaction is quite different from the query transaction because a single peer cannot on its own update the ledger. Updating requires the consent of other peers in the network. A peer requires other peers in the network to approve a ledger update before it can be applied to a peer's local ledger. This process is called consensus, which takes much longer to complete than a simple query. As we know, query is a simple process where you ask for some input, you query the ledger and you will get the output. But when it comes to update, a consensus has to be reached among all the peers who are participating in that transaction, which are present in the network, and they have to come to a conclusion that this is the
Thanks for watching. Feel free to add your questions as comments down below.
particular block that we need to add it to the local ledger of our peer. I mean, each peer. So this consensus must be reached, and it is much more complicated when compared to simple query. So the ordering service, the ordering service takes up the consensus process in three steps, which are as follows. So in the first step, the application work with the subset of endorsing peers. As we know, endorsing peers has chain code installed on it, each of which provide an endorsement of the proposed ledger update to the application, but do not apply the proposed update to their copy of the ledger. So this is the first phase. Next, these separate endorsements are collected together as the transactions and packed into blocks. In the third and final phase, these blocks are distributed back to every peer where each transaction is validated before being committed to that peer's copy of the ledger. So this is a three-step process which is needed to update the ledger in Fabric. In addition to their ordering role, Ordero also maintains a list of organizations that are allowed to create channels. This list of organizations is known as consortium, and the list itself is kept in the configuration of the orderer system channel, which is also known as ordering system channel. So Ordero also enforce basic access control for channels, restricting who can read and write the data to them and who can configure them. Remember that who is authorized to modify a configuration element in a channel is subjected to policies that the relevant administrator set when they create the consortium or the channel. The practicality of um, this configuration you can see in the practical section, which is the next upcoming section. So in this section you will find YAML files where we will write the configurations which we have mentioned over here in those YAML files, which we will see. And when you see that configuration file, you can relate these definition to the configuration file. So as we've seen that the different types of orderer exist. First is Solo and Kafka and Raft. Now Solo and Kafka is deprecated as part of 2.0 release, and Raft is a recommended ordering service to use. So Raft is easier to set up. Kafka and Zookeeper are not designed to be run across large network, and Raft is supported natively, which means that users are required to get the requisite image which are already present or which already there or provided by Hyperledger Fabric, and learn how to use Kafka and Zookeeper on their own. Whereas Kafka uses a pool of servers which are called Kafka brokers, and the admins of the order organization specifies how many nodes they want to use on a particular channel. Raft allows the user to specify which ordering nodes will be deployed to which channel. So Raft is the first step towards Fabric's development of a Byzantine fault-tolerant ordering service. We have seen what Byzantine general problem is, and what is Byzantine fault tolerant in our previous section. So Raft is the first step towards solving that issue in Hyperledger Fabric. So this is about ordering service or orderer. In the next section, we are going to look into Fabric Certification Authority, which is Fabric CA. Until then, we will see you in the next section. Please revise this. Welcome back, everyone. In this section, we are going to look into one more component, which is Fabric Certification Authority. Fabric Certification Authority is a private root certification authority provider capable of managing digital identities of Fabric participants that have the form of X509 certificates. Because Fabric CA is a custom CA targeting the root CA needs of the Fabric, it is inherently not capable of providing SSL certificates for general or automatic use in the browser. So all these concepts that I am explaining here are more into configuration details. To get to know more about the configuration details, please do check out our lecture Hyperledger Fabric for System Admin on bootcamps. So Fabric Certification Authority is a custom implementation of Certification Authority, and it is an alternative to CryptoGen tool, which is provided by the Hyperledger Fabric by default. Why is this needed? Why is it necessary? What does it help with? Certification authority helps in registration of the identity. Identity may be an application, a peer, anything, and it helps in enrollment as well. So this is about the certification authority. In the next section, we are going to look into what ledger is in Hyperledger Fabric. Welcome back again. In this section, we are going to look into another component of Hyperledger Fabric, which is ledger. So ledger stores important factual information about the business objects or assets. Ledger consists of two parts. First is world state and the blockchain, which is nothing but the transaction log. The world state can be stored in two databases. First option is LevelDB, which is the default database, and you can also improve it to CouchDB. So CouchDB, or if you have CouchDB, you can run complex queries, which we will see in the practical section as well. The ledger is the sequenced, tamper-resistant record of all the state transitions in the fabric, while state transitions are a result of chain code invocations or the transactions submitted by participating parties. Each transaction results in a set of asset, which is key value pairs, that are committed to the ledger as create, update, or delete transactions. So the ledger is comprised of blockchain, which is why it is called blockchain, which is a block of chain, to store the immutable sequenced record in blocks, as well as the state of the database to maintain the current fabric state, which is the world state. There is one ledger per channel. Each peer maintains a copy of the ledger for each channel of which they are a member of. Ledger features. So query and update ledger using key-based lookups, range queries and composite queries can be done on ledger. Read-only queries using a rich query language, that is, if you use CouchDB as a state database, you can run read-only rich queries on that. Read-only history queries, which is query ledger history for a key, enabling data provenance scenario. So all these functions, all these query or query history, so you are going to see it in the practical section where you run, where you write the code for each of the transaction. So transactions consist of versions of key or values that were read in the chain code, which is called read set, and the key and values that were written in the chain code, that is called the write set. The transaction contains signature of every endorsing peer and are submitted to ordering service. This we have already seen in the ordering service. Transactions are ordered into blocks and are delivered from an ordering service to the peers on the channel. So peers validate the transaction against the endorsement policies and endorse the policies. So basically, peers, when peers get the transaction, it validates the transaction against the endorsement policy, which will be defined for every peer. So you will see the definition how we are going to define the endorsement policy in the coming section. So the peers will validate these transaction against those policies. Prior to appending a block, a versioning check is performed to ensure that states of the assets that were read have not changed since chain code execution time. There is immutability once the transaction is validated and committed to the blockchain. A channel's ledger contains a configuration block defining policies, access control list, and other pertinent information. So this information you can see in a configuration file in the lab section. Channels contain MSP or membership service provider instances allowing crypto materials to be derived from different certification authority. As we know, to talk to the network, every entity who is participating in the network should have a certificate, authorized certificate, which is provided by the membership service provider. So those certificates are used. So you can picture ledgers like this. Consider P1 as the peer, and it has S1, which is a set of smart contract, and you have another S1 and you have S2. So you have one set of smart contract and you have one ledger. You have another set of smart contract and you have another ledger. It may occur that there exists a smart contract and you don't have a ledger. So this is about ledger. In the next section, we are going to see the properties of another component, which is channel. Thank you for watching. So in this section, we are going to look into another Hyperledger Fabric component, which is channel. So what do you mean by channel? So channel is a mechanism by which interested peers within a blockchain network can collaborate and communicate. A Hyperledger Fabric channel is a private subnet of communication between two or more specific network members for the purpose of conducting private and confidential transactions. In Hyperledger Fabric, we have system channel and we also have application channel. So, what are the characteristics of a channel? A channel is defined by members or organization. An anchor peer is also defined per organization. A shared ledger is defined, the chain code applications as well, and ordering nodes as well. Each transaction on the network is executed on a channel where each party must be authenticated and authorized to transact on that channel. Each peer that joins a channel has its own identity given by MSP, which is Membership Service Provider, which authenticates each peer to its channel peers and also the services. So the election of leading peer or the leader peer for each member or each organization on the channel determines which peer communicates with the ordering service on behalf of the organization. No ledger data can pass from one channel to another. This is a very important point to remember. The separation of ledger is very important in Hyperledger Fabric. That is its main feature. So this separation of ledger by
If you have enjoyed watching this video, please subscribe to our YouTube channel. Thank you.
channel is defined and implemented by configuration chain code. The identity membership service provider and the gossip data dissemination protocol helps to do this. So to create a new channel, the client SDK calls configuration system chain code and references the properties such as anchor peers and the members or the organizations. This request creates the Genesis block for the channel ledger, which stores the configuration information about the channel policies, members, and anchor peers. In the coming section, which has the lab, so in that section, you are going to learn how you are defining the anchor peers, the organization present, and how you are going to create the Genesis block. So when adding a new member to the existing channel, either this Genesis block or, if applicable, a more recent reconfiguration block is shared with the new member. The channel and its detailed configurations are converged in depth in our Hyperledger Fabric system course, which is a separate course. Please do subscribe for that course to get more information about the configurations of the channel which we are talking here. But the beginning introduction is covered in our lab section. But to get into deeper knowledge of how this configuration works in Hyperledger Fabric, please do subscribe for Hyperledger Fabric for System Admin course in bootcamps. That is it for channel. In the next section, we are going to look into what smart contracts are. See you in the next section. In this section, we are going to see smart contracts. What are smart contracts? Smart contracts are nothing but business agreements or business logic that is encapsulated in the form of code. The smart contracts versus chain code. Some people uses interchangeably, but that is not true. So smart contracts are meant to contain the logic that gets executed and interacts with the ledger in order to manage and maintain the state of the asset. On the other hand, chain code governs the administrative aspect of smart contracts. That is how smart contracts are packaged in a chain code and then deployed on the network. So this is the difference between smart contract and chain code. So how the smart contracts work? So when a transaction request comes in, the contract the deployed when you deploy the chain code, you will get the contract ID. So when the transaction request comes in with the contract ID, the transaction dependency, it will look for any dependencies that are there for this transaction, and the peer also checks for the current state or the current ledger state that is present. Next, as part of this process, the smart contract interprets the process or the request. As part of interpreting the transaction, it looks for the current state of the ledger, and it also looks for the deployed business logic in terms of the smart contract. So after looking into the current state and also the business logic, the output will be whether it is accepting the transaction request or not, or the correctness or attestation based on the different policies that you have defined. And it also gives the state delta. Delta is the difference between the current ledger state and the modification that has occurred because of the transaction that we have executed, and other ordering information. So these are the processes that goes through when the transaction request occurs on a peer. So this is how the smart contract works. So when you invoke a transaction on a peer. So the practicality of this, how you need to invoke it and what all the other processes involved, so that you will see it in the practical section. So stay tuned. So that is it about smart contracts. In the next section, you are going to look into what are fabric policies. So stay tuned. Now let us see what do you mean by fabric policies. So policies in Hyperledger Fabric are implemented at a different level. So each policy domain governs different aspects of how a network operates. So in a nutshell, this is how Hyperledger Fabric policy hierarchy looks like. So you have system channel, which consists of which can manage consortium membership and blockchain structure. You have application channel, which can manage transactions on the network and the business logic. You have access control list, which is ACL, and smart contracts, which can manage the transactions, data, and events. So we'll look into how this channel, system channel, application channel, and ACLs will can be configured in the next coming section. So system channel. So system channel configuration. So every network begins with an ordering system channel. So there must be exactly one ordering system channel for an ordering service, and it is the first channel to be created. The system channel also contains the organizations who are the members of the ordering service or ordering organizations, and those that are on the network to transact, which are also consortium organizations. So application channel configuration. Application channels are used to provide private communication mechanism between organization inside consortium. Please don't confuse between the private communication mechanism with consortium. Consortium is a group of organization who can have a channel. Inside that channel, if two organization wants to have private communication, you can go for application channel. The policies in an application channel governs the ability to add or remove members of the channel. The application channel also governs which organizations are required to approve a chain code before the chain code is defined and committed to the channel using Fabric chain code lifecycle. Next, coming to ACL or access control list. The network administrators will be interested in the Fabric use of ACL because it has the ability to configure access to the resources by associating those resources with existing policies. ACLs refers to policies defined in an application channel configuration and extend them to control additional resources. The default set of Fabric ACL is visible in config.tx.yaml file under the application under this section, which is application ampersand application default section. So this has to be overridden for your different environment, for example, testing and staging and production environment. So we're going to look in details about what do you mean by config.tx file and what is this application default section is all about in the practical section. So the fabric policies are flexible and can be configured to meet the needs of the network. The policy structure naturally leads to a division between the domains governed by either the ordering service organization or the members of the consortium. So the details of who covers what or like which service is covered by which organization. For example, as I told before, it's it says that So couple of the domains are governed by ordering service, and couple of them are uh, you know handled by or governed by members of the consortium. So all these configurations, in-depth configurations of how you should do the configurations for ACL, for configuration for system channel and the application channel in deep, is covered in Hyperledger Fabric System Admin course in Bootcamp. Please do subscribe for that channel if you subscribe for that course if you want to learn in-depth knowledge of configuring all this. But if you want to understand at a high level, in the practical section when we do Hyperledger Fabric hands-on, so in that section you will get a brief about how we have defined all these policies. So this diagram tells you the Hyperledger Fabric policy hierarchy, as you can see, which is governed by what. So as you can see, this partition that you can see over here, this is what is governed by orderer. On the partition on the right side is governed by the consortium organizations. As you can see, so the system channel is governed by orderer, which is responsible for blockchain structure, consensus, consortium membership, consortium member policies, which can be categorized under reader, writers, and admin. And it is also responsible for application channel, which is consensus. And what are the things that comes under consortium organization? So consortium organization can govern the channel modification, channel membership, or organization policies, smart contract, ledger data, and events. So in-depth knowledge, again, as we told, please do subscribe for the admin system admin channel in Bootcamp. That is it for this lecture. In the next lecture, we're going to see what do you mean by endorsement policies. So stay tuned. Now let us look into what do you mean by endorsement policy. So endorsement policy is nothing but a policy that defines smallest set of organizations that are required to endorse a transaction in order for it to be valid. It is described or set during chain code instantiation. So the principles are described as MSP.role, where MSP represents the required MSP ID and role represents one of the accepted roles, which is either member, admin, client, or peer. Now let us look into a couple of examples of valid principles. So when we say arg0.admin, which means that any administrator of organization 0 MSP, which internally means any administrator who holds organization zero's membership service provider, otherwise the certificates, which is X4509 certificates, which I'm talking. So, sorry. And the second example, org1.member. This means any member who's holding org1 MSP. Org1.client. This means any client of organization 1 MSP. Org1.peer. Any peer of org1 MSP. So this is the syntax that is used in order for us to express the endorsement policies. So as you can see, you have this expression. So expression takes the value either and or out of, and E is either a principle, and you can nest those inside all this, which is, so if you don't understand how you are nesting the expression, we are going to provide a couple of examples for you to understand, and we will look into all the endorsement policy syntax in the practical section as well. So don't worry if you don't understand this expression. So as I've told before, expression takes the value and or out of, and E is either a principal or another nested call to the expression. Now let us see a couple of examples so that you can understand this policy syntax better. As we have seen, this is the expression which takes and or another one, other one which we have discussed, which is out of, right? So here we are having and or. So let us understand. So this is and or, which is open parenthesis, and after that you have arg1 dot
Thanks for watching. Please like and share this video.
member, arg2 dot member, or arg3 dot member. So from this, you can read this policy as follows. So in order for this transaction to be valid, the policy requests one signature from each of these three principles. So why each of the three principles? Because you have and as an expression. So if you have or as an expression, as you can see in the second example, or arg1 dot member, arg2 dot member, for the transaction to be valid, it requires one signature from either one of the true principles. As we can see, since we are using or, you can use either, like either of these can be used. So again, one more example, or arg1 dot member, and which this is what we have talked, which is the nested expression. It requests either one signature from a member of organization 1 MSP, which is this part of the expression, or one signature from a member of arg2 and arg2 MSP, and because it is and one signature from a member of R3 MSP. So for this transaction to be true, the arg2 member and arg3 member, both of them have to have to vote. After that, either of them should turn true in order for this transaction to be valid. So this is how you're going to read the endorsement policies. So you will get to know how the practicality of it when we try our hands on the practical section. So the transaction validation is, so as part of transaction validation, there are a couple of steps that are performed, and we will look into each of those steps. So each validating peer checks to make sure that the transaction contains appropriate number of endorsements. The transactions are from the expected source, which means both of these specified in the endorsement policy. The endorsements are also checked to make sure they are valid. That means they are having valid signatures or valid X509 certificates. So the ways to set endorsement policies in Fabric is setting chain code level endorsement, and you can also set collection level endorsement policies, and you can set key level endorsement policies. This itself is a topic, so you can go read more about this on the course page, which is available on the course doc, which is available on the course page, to get to know more details about endorsement policy. So there is a concept of private data. So private data collection, you can also specify in an endorsement policy at a private collection level. So you can specify the endorsement policy in different level, as we have seen before. So private data collection you can specify using endorsement policy. So this will override the chain code level endorsement policy for any keys in the private data collection. So there are cases where it may be necessary for a particular public channel state or private data collection state to have a different endorsement policy. This state-based endorsement allows the chain code level or collection level endorsement policies to be overridden by different policies for a specified keys. So as we have told before, to get more information on how this works and how to define all this, please go through the course doc available on the course page. That is it about endorsement policy. In the next section, we are going to look into what do you mean by membership service provider or MSP. Stay tuned. In this section, we are going to look into an important component of Hyperledger Fabric, which is membership service provider. So why membership service provider is needed and what does it do for Fabric network? A mechanism that provides members with a set of roles and permission within the network is the responsibility of membership service provider. As we know, every entities who are participating in the Fabric network must identify themselves using a certificate. So there are different types of MSP. One is local MSP and channel MSP. So certification authority or certificate authority issues identities by generating a public and private key, which forms a key pair that can be used to prove identity. Because a private key can never be shared publicly, a mechanism is required to enable that proof, which is where MSP or membership service provider comes into picture. For example, a peer uses its private key to digitally sign or endorse a transaction. The MSP is a mechanism that allows that identity to be trusted and recognized by the rest of the network without ever revealing the member's private key. Now, the what is the actual difference between the MSP and certification authority? So, certification authority generates the certificate that represents the identity. On the other hand, MSP contains a list of permissioned identities. Also, it is the MSP that turns an identity into a role by identifying specific privileges as an actor has on node or channel. Note that when a user is registered with the Fabric CA, a role of either admin or PO, client, orderer, or member must be associated with the user. This is about MSP. In the next section, we are going to put in all the concepts that we have learned so far, all the components that we have learned so far, and we are going to see how the architecture looks like when we include all these components in the fabric. And we will see the working of fabric, which includes all this component. See you in the next section. Welcome back, everyone. In this section, we are going to combine all the topics, all the components that we have learned so far, and we are going to combine them to see how they work in Hyperledger Fabric in togetherness. Now, let us see in this slide, this is the simplest network. As we move forward in the next slides, you can see I'm gonna increase the complexity of the network. As you can see in this, you have a blockchain network, you have peers, and each peer is associated with smart contract and ledger. As you can see, we have three peers, peer 1, peer 2, and peer 3. And peer 1 is associated with the smart contract 1, peer 2 is associated with smart contract 1, peer 3 is also associated with smart contract 1. Similarly, ledgers or same ledger is associated with P1, P2, and P3. It is not necessary that you have the same smart contract and same ledger associated with all the peers. It will change as the network evolves. Now in this section, we are going to introduce some more components. So in the previous slide, we have seen only this part, which is pure smart contract and ledger. In this slide, we have introduced channel, application, and ordering service. As you can see, channel 1 is associated with P1 and P2, and application 1 is connected to channel 1, which has internally connected to P1 and P2. And you have channel 2. Channel 2 is connected to PO3 and PO4. PO4, and application 2 is connected to channel 2, and channel 2 talks to P3 and P4. So we have one more service, which is ordering service. So ordering service takes all the transaction, converts it into block, and it delivers to all the peers. Peers will take the block, it validates the block, and it adds to its local ledger. Now let us complicate this structure even more and see how Fabric works in its entirety. As you can see in this picture, you have certification authority, you have application, you have POs, you have smart contracts, you have ledger, you have orderer, channels, consortium, and you have channel policy, and you also have network policy. Now let us understand how all these work together. As you can see, certification authority is mainly responsible for providing the certificates. As you can see, certification authority CA1 is providing certificates to application 1 and PO1. Similarly, certification authority 2 is providing certificates to application 2 and PO2. Certification authority 3 is providing certificates to application 3 and PO3. Certification authority 4 is providing certificate to ordering service, as you can see here. Now you can see there are two channels, one is C1 and C2. So for C1 channel, P1 and P2 are connected to C1, which is channel 1. So who will decide which POs has to connect to channel? That is where consortium comes into picture. As you can see here, the organization A and organization B has come to a consortium, and it has to abide by the channel policy CP1, and channel policy CP1 has to be followed for this channel C1, and RA is the organization A owns PO1 and P2 is owned by organization B. So they form the consortium and they form this channel. This is C1. As you can see, as this is part of RA and RB, application A1 and application 2 has access to C1. And it is ordered by the orderer O, which has to follow the rules, which is the network property, and it is owned by another organization, which is RD. Now moving on to the next channel, which is C2. As you can see, C2 is formed by RB and RC, which is organization B and organization C. As you can see here, P2 peer is part of C1 and also C2. So C2 is connected to P2 and P3, as you can see here. So, and in this diagram, A3 is the application which can connect to C2, which is channel 2. As you can see, the smart contracts have deployed on channel 1, which is smart contract 4 and smart contract 5 as per channel 1 on PO1 and PO2 respectively. As part of channel 2, on PO2 and PO3, we have smart contract 5, which is deployed on channel C2. That's why P2 and P3 has ES5 smart contract and L2 ledger associated with ES5 smart contract. As you can see in this picture, P2 is part of both channel 1 and channel 2. So that is the reason it has two smart contracts installed on top of it, and it is also associated with two ledger. So this is how the peers and applications and certification authority and the formation of consortium and ordering works. So as you can see, we have only one orderer here, which is handling both channel 1 and channel 2. And this orderer is responsible for taking all the transaction and creating
Thanks for watching. Feel free to add your questions as comments down below.
the blocks according to network policies, which are defined by the organization D, which is RD. So in entirety, this is how the fabric network works, or this is how the fabric network formation happens. And these are the entities that comes together to form a fabric network. This is the explanation that I have just explained you. So feel free to go through it until you understand the concept. It is very important to understand the working of fabric, including all the components that we have learned so far. Please feel free to go through this again until you understand the concept really well. So that is it for this section. In the next section, we are gonna prep ourselves for coding in Hyperledger Fabric, and so we are gonna install all the required software and packages. So that's it for this lecture. Stay tuned. So in this section, we are going to learn the installation of software and the packages that are needed for Hyperledger Fabric. The recommended operating system for Hyperledger Fabric development is Linux OS, but if you are using Mac and Windows, there's absolutely no problem. But there are a couple of steps that you need to do extra for Windows if you are using Windows. So for Linux OS, you don't have to explicitly install Python because Python is inherently there in Linux OS. So you don't have to explicitly go and install Python. So these are the lists of packages and softwares that you have to install for Hyperledger Fabric. So Git is required, which is the repository with which we are going to get our Hyperledger Fabric base code from, and CURL is required to get the repository from Git or get all the packages from Git. We need Docker and Docker Compose to containerize the application and run all the application as containers. So we are going to learn about what containerization and how we are going to run applications or components as containers in the practical section. We need Go because Hyperledger Fabric is written in Go, so we need to install Go as well. We need Node.js and Node Package Manager as well. So if you're using Windows OS, you need to have all those which I have mentioned in the previous slide, and you also need to install Python on your own, and you also need to install a little bit of extra steps that you need to take in order to install Docker and Docker Compose. All these are very much available on Google, so try to Google it and try to install all this. Meanwhile, I am using Mac OS, so I'm going to show you how it should look like when you install all this. So let me just go through this and open up a terminal and show how it should look like. So I'm checking the curl. So this is how you should get if you have it already installed curl, and I'm going to check npm version. So I have this, and let us check Docker version. Sorry, Docker minus version. So you have this, and let us check Docker Compose. So I have Docker Compose installed as well. Let me check Go. So I have Go. Let me check Python. So I'm using Mac OS, so I am good to go with Python. Let me exit. Okay. And so you have check, okay, check Node.js and also check Git version as well. So I have all the packages installed. So this is what it should look like if you already have installed all the packages that I've just mentioned. Now moving on. So if you have any questions or any queries that you need that needs to be answered, please feel free to reach out to us in case of installation problems. So we do offer private tutoring sessions for all these courses. Please do subscribe for private tutoring sessions as well. So it will be helpful for you if you are stuck with any debugging, or if you are stuck with an application, or if you need extra extra effort or extra guidance you need to from our side. So that is where private tutoring comes into picture. So please do subscribe if you want to learn more or get most out of this course, and in hand, or more guidance on all these projects and the theory sections as well. So we do have other courses on the one important course is Hyperledger Fabric for System Admins, which talks in-depth knowledge of how you're going to set up the system and all the configuration needed for setting up the system. So that is one course that you can definitely check out with this course as well, which will give you the boost that you can set up a Hyperledger Fabric network as well, and also you can deploy and write the smart contracts. So it will be a plus point if you know both. So this is the linked um, is the link for system admin Hyperledger Fabric course. Please do subscribe and check out. So if you have any questions or any more doubts on the existing topics, please do feel free to reach out to us. And also, next upcoming section is about lab, which is basically the hands-on on programming and setting up the network. So which will be more interactive, on more towards programming side of it. So stay tuned, and I'll see you in the next section, which is the programming section. Welcome again. I congratulate you for finishing this course, Introduction to Blockchain Development with Hyperledger Fabric by Coding Bootcamps. In this course, you have learned the overview of blockchain technology. You have seen the anatomy of blockchain technology. You have seen Hyperledger blockchain ecosystem. You have got in-depth understanding of Hyperledger Fabric components and architecture of Hyperledger Fabric. With that, we have also built a distributed application, which is a built supply chain distributed application with Hyperledger Fabric. In that process, we have learned how to design the supply chain, how to write the chain code, how to compile and deploy the chain code, running and testing the chain code, and we also developed an application with Hyperledger Fabric through SDK. Now, after this course, you should be confident enough to explain what blockchain technology is and what are the components of Hyperledger Fabric in details, and how those components work together in Hyperledger Fabric ecosystem. I congratulate you again for successfully finishing this course. You can take up the follow-up classes which are mentioned here. My suggestion would be to take up Hyperledger Fabric for system admins, where I will explain you or I will guide you through the network setup for Hyperledger Fabric in detail. If you want to check out other courses as well, please click on those links and you can check out those related courses as well. Please do visit us on coding-bootcamps.com and please do follow us on all the social medias. Thank you for watching. I wish you good luck.